So today I'm going to introduce you to something called Surds, and it makes sense to start off with, well, what is a Surd then? And it's actually surprisingly difficult to describe. I've talked to quite a few maths teachers and they don't all necessarily agree exactly on what the definition is. So we will go with, it is a number that involves a root, and when you take the root of that number, you get something called an irrational number. So the answer you get is, it doesn't terminate, it's a decimal that goes on forever, and it doesn't recur, so you don't get a repeating pattern in those. So the square root of 2 it's 1.41, blah, 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 and it just goes on and on and on. So that one does count as a surd. Root 5, same sort of thing, that will go on forever and it doesn't recur. Root 16, on the other hand, that is exactly 4. So it's not a decimal, it's just the number 4. So this one's not a surd. Root 90, now chances are you don't happen to know that one, but because 90 is not a square number, so the square root of 90 will be something irrational. It's worth pointing out that it's not just square roots, so the cube root of 9, well, what number do you do? This number times itself to give you 9. Well, it's not a nice one, it's an irrational one that goes on forever. So that counts too. The cube root of 8, well, that's actually the number 2, because 2 cubed is 8. So this one's not a surd. The fourth root of 11, yep, that's going to be something awkward. It's not a nice number, so that counts as a surd. The square root of negative 7 is a bit of a debate one. You can't do the square root of negative 7. I'll just show you very quickly. If we try square root of negative 7 on a calculator, it says there's a maths error. Now, that's because it involves a piece of maths called complex numbers. So when I say you can't do it, what I mean is, at the moment with the maths that you're expected to know, there isn't an answer to that. Whether what you get when you do it using A-level maths, whether that counts as a surd or not, is something that's a little bit up for debate. I think it probably does, but not something you need to worry about. I just want to throw in pi, because pi is one of those irrational numbers that goes on forever and it doesn't recur and it doesn't repeat. But because it's not involving a root, it's not a surd. You never get asked, is this a surd or not, but it's just worth having a think about them. One thing that just popped up was irrational numbers. An irrational number, I-R-R-A-T-I-O-N-A-L, is a number that you can't write as a fraction. So I've already highlighted this. You might like to pause the video now and make that important note and highlight it. Remember to use as many highlighters as you have available to you. Cool. So here's one of the things that I really want to show you that I think this is just amazing. So let's just have a quick look at this. The square root of 3. Although it is true that cube roots and fourth roots do count, at GCSE level you only have to deal with square roots. So let's just have a quick look at what the square root of 3 is. So calculator helpfully says the square root of 3 is the square root of 3. Thank you, calculator. So we need to get the decimal equivalent for that. So it's about 1.73, let's write this down, 1.732050808, and it's approximately that, because really there's more decimals here. This has just rounded it to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places, but it actually goes on forever. I do the same sort of thing with the square root of 12. So it does a weird thing first. It tells you that the square root of 12 is equal to 2 times the square root of 3, which is interesting, and we will come back to that in the second video. But for now, I want the decimal version. 3.464, 101615. It's about that. I want to show you something really cool. So I'm going to multiply those together. Root 3 times root 12. And have a guess. What do you think that's going to be? What do you reckon it's going to come out? 1.73205 blah, 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 times that one. I mean, that's kind of about 2, and that's roughly about 3-ish. So 2 lots of 3 is going to be somewhere around about 6. But let's see what the calculator tells us for this one. So root 3 multiply, oh, hang on, need to get out of that root, yep, times, multiply by root 12. So root 3 times root 12, what's that going to equals? I'll press equals. It's exactly 6. 6, not about 6, it is exactly 6, and that is mind-blowing. It is 6 on the dot. So this irrational, non-recurring, non-repeating decimal 1.73205, which is literally infinitely long, multiplied by this other different irrational number that is infinitely long. When you multiply these two together, you get exactly 6. Now that is amazing. If you are not finding yourself having to sit down, or I'd imagine you've already stopped this and you've reached for your phone to actually call up everybody you know and just tell them this thing. If you're not amazed by that, I'm afraid there is something wrong with you. Cool. So let's have a look at some of the things that we can do. You should have had a go at the true or false thing. So hopefully you found out that if you do something like the square root of a number and you multiply it by the square root of another number, that is the same thing as just multiplying those two numbers together and then taking the square root of that answer. And that's not an obvious thing. It's not obvious that that should happen, but it is true. Root a divided by root b. So that also can be written like this, the square root of a divided by the square root of b. And it turns out that that is the same as doing a divided by b first and then taking the square root of that answer. That's really cool that that works. So multiplying and dividing works nicely. Hopefully you found that root a plus root b does not give you the same answer as if you add them up and then you take the square root of that. So that doesn't work. And similarly with subtracting them, if you do root a minus root b, that is not the same answer as doing a take away b and then taking the square root of that. So that's not okay either. So it works nicely with multiplying and it works nicely with dividing like that. That's really nice. Adding and subtracting are not quite so nice. You can do stuff like this. So if you've got 5 lots of root 2 and you're trying to add on 3 lots of root 2, then we can go ahead and say that's the same as 8 lots of root 2. That's fine. And 6 lots of root 7, take off 2 lots of root 7. Then sure, that's 6 take away 2 is there's 4 lots of root 7 there. That's okay. Right, what else? Okay, so just a last thing for now. This is one of those things that really sort of helps demonstrate whether you understand what square roots mean. So if you take a number and you square it, and then you square root it again, you should be back where you started. Back where you started. Similarly, if you take a number and you take its square root, but then you square it, you also get back where you started. So squaring and square rooting are inverse operations. And it's things like this. This is the real test. Root 5 times root 5 is, well, it's 5. That's what square root means. Square root means what number do I have to times by itself to get this thing here? So the square root of 5 is the thing that I have to times by itself to get 5. And here I am timesing it by itself. This is the square root of 5 times the square root of 5. Or the thing I have to times by itself multiplied by the thing that I have to times by itself to give me 5. Well, it's 5. It's really common. See if you can avoid doing this. It's not the end of the world, but it's really common to see people doing this sort of thing. The square root of 3 times the square root of 3. Oh, I've got a rule for that. I know that I can times those together, which is 9, and it's going to be the square root of that. And the square root of 9, I know that that's 3. And yeah, that's true, but square root of 3 times square root of 3 is just 3. That's what it means. If you do find yourself doing that, not the end of the world, but something to bear in mind. So I'm going to highlight this one in real time. Quick little tip for you if you have a ruler like this. If you turn it face down, then first of all, people don't know it's a one direction ruler, but also this edge here, if you rest your highlighter against that, then it won't smudge when you lift it up. So it's a handy little tip for just in case there's anybody out there that actually enjoys highlighting and hasn't really found this useful tip yet. You'll notice I'm only using one colour here, which frankly I'm a little disappointed with myself, but feel free to knock yourself out with as many highlighters as you find. Right, see you next time.